Okay, welcome everybody. This is going to be the first in a series of videos dealing with mathematical integration. Now, when you're dealing with integrals, you have a relationship between antiderivatives and integrals, and a constant c is needed to represent an entire family of functions. And integration is basically used to measure voltage, wattage, area under the curve, distance traveled, things like that. So without further ado, the first method of integration we're gonna use is something called u-substitution. And basically, when you have a u-substitution problem, you wanna look for an integral that's differentiable to each other. Say for instance, you have the integral 1 plus x to the fourth dx. Now notice how this function here is differentiable, to this. So when you select your the differentiated version of u would be this. Case in point, you have u is equal to 1 plus x to the fourth. So your derivative of this, your du, is going to equal 4x to the third dx. So in this case, you go ahead and plug in u for this, and your du, remember, is equal to 4x to the third dx. So you want everything in terms of u. So you put this du, and du accounts for this 4x to the third dx. So when you take the square root, you get rid of the radical symbol. You know the radical symbol turns to 1/2. So now when you're ready to integrate, 1/2 plus 1 is equal to 3 seconds, and you bring down the 2/3 u to the 3 seconds, and this is the integrated version of this. And now you're ready to plug in your u, which is going to be 2/3 to the 1 plus x to the fourth to the 3 seconds. And remember, you have to put in your constant c, because your constant c represents a whole family of functions.